Hello, protocols, packets, and programs. We've crossed the summer solstice, with nights now getting longer and days getting shorter. If AppSec had a solstice, it'd be more like the list of CVEs getting longer, lines of code getting longer, the number of top 10 lists getting longer, and release times getting shorter. Which means this week we talk with Nyffenegger about finding the time for manual code reviews, bringing meaningful bugs to daylight, and putting poor practices to sleep. Check the sky and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. Think your terminal emulation is secure? Think again. Passwords and firewalls alone won't protect you. Cyber threats are evolving, and so should your security. Rocket Secure Host Access gives you phishing-resistant, password-free protection with leading-edge encryption. Your mission-critical systems deserve more than good enough. Secure your green screen access and stay ahead of the threat. Rocket Secure Host Access. The future of TE is now. Learn more at securityweekly.com/rocketsoftware. This is episode 337, recorded for June 30th, a little bit before then, 2025. I'm your host, Mike Shima, and I'm here with some new friends, Mandy Logan. Hey, Mandy.
Welcome to you. I'm so glad you got to be here. No, it's a welcome. I was going to say that it's a welcome change to see you again after RSAC. I mean,
yes,
that's literally the only time RSAC. I get to see you in person, right?
Yes, and in the spirit of RSAC, I'm sure we'll manage to talk about AI
yes.
at one point. So yeah, but hold your horses. We've also got some other friends joining us. Josh Marpet is here. Hello again, Josh. It's been quite a while.
Here. Yeah, it's been a long time since I've been on ASW. This is awesome. Thank you for inviting me.
Well, it's going to be even more awesome because we have Louis here, who's the founder of Pen Tester Lab, the creator of hundreds of hands-on web security labs, and a veteran pen tester, AppSec engineer, and code reviewer. He speaks worldwide about security code reviews, secure coding, JWTs and SAML, and training red, blue, and AppSec teams to uncover high-impact bugs buried deep in real code. Hello, Louis. Thank you for joining us.
Hello. Thanks for having me.
So this is, as promised, we'll get into some LLMs and some AI, but let's spend some time with humans for a bit first, if you don't mind. And part of this, or the thrust of this, is talking about code review, but very specifically manual source code review, throwing humans at this. So not so much the linters, the compiler feedback, or SAST or DAST for that matter, but manual work, which honestly can get kind of tedious. But maybe let's set something up about what, from your perspective, what's a good manual source code review? What are we talking about when we want to spend time with humans doing this?
So I think a lot of people find code review tedious because they're not necessarily doing it well. A lot of people do manual code review, but it's basically running grep or running a SAST and then manually review the findings. And if you're doing that, I totally understand you will find code review very frustrating, because a good part of code review and the appeal of manual code review is you kind of in an adventure in the source code and you understand how things are working, what is happening, how people did things, how the code was written, and why they wrote it this way and not another way. And then from time to time in your adventure, you stumble across vulnerabilities. But the good thing is that even if you don't find the vulnerabilities, you learn new things about code base. And that's why it's a lot more interesting than just going through a list of checks or like something coming from a robot, from an AI, from a SAST, and one at a time checking that list. Like, it's a very different mindset, and that's what I'm trying to advocate. And sometimes you can't do the adventure, you need to do the hard work. But if you have the time, or even if you can spend a little bit of time going in an adventure, as opposed to like manually grinding a checklist, you may find that manual code review is for you.
Yes, as someone who plays D&D a lot, I love
know,
a good
roll
dungeon
for
crawl.
initiative on your code review. I'm literally
Yeah, exactly. And part of that adventure, what I already love about this and appreciate is that checklists bad, understanding good, because the checklists, as you say, they're tedious. They're also just so generic. You can just script up a couple greps. Why bother with the checklist anyway? The understanding, I strongly appreciate, like I said, but that can also be tough because one of the aspects of manual code review is it can take a while just to understand the code before you get to that point where admittedly everybody says, why do they write it like this? Looking at someone else's code is always worse than your own code, right? That's a little bit of how things work out. What does it mean to understand the code from a security perspective? Do you have a couple, like, I'm trying to avoid now saying checklists, but what are some good patterns that you try to look for or a nature of understanding?
So I think first, we're going to get AI out of the way right now. You can use AI to gain a first level of understanding. People published recently like deepwiki.com, which is basically something that you can point as an open source GitHub repository. And it's going to give you like the global architecture of the code base, which is often the more intimidating part of code review is getting started. That helps you get started. Then you have a lot of patterns you can come across. Like, for example, people are filtering some bad values, and then they are modifying the value, and they may reintroduce things they filtered. And there are like a lot of filtering like that, not always using the same value, or not handling some edge cases. Like, you have a lot of patterns. But I think the most important thing is also not necessarily going through that list of patterns, but really like working on the code and find as well those like unknowns that are not part of any pattern, are not part of any checklist, are not part of any grep regular expression. Just like the magic of finding things that you never thought someone could write.
Yeah, I think what's interesting there is there's a couple things that are sort of, I'll say the easy bugs. You use string concatenation for a SQL query, or you're writing something to HTML that's going to turn to XSS. There's hard bugs out there, but to be a little bit trivial, it's easy to say there's a hard bug, but I think it's harder to explain, or what is a hard bug? What is the bug that you would rather you would unleash a human on to find that you're getting value out of this code review?
Well, I feel like that goes kind of with the question I had on what is your determining factor for if you have to section out the code for a human review, which parts would you say, yeah, these are the most critical? Which parts do you really want good human eyes on?
So I think what you can do is get the AI, the SAST out of the way when you start, and then focus on parts that you think are critical. But I think everything that deals with complexity, deals with crypto engineering, all things that vulnerabilities for those kind of features are not necessarily well documented online. AI, SAST, grep are very good because they are based on matching patterns that we already know. And unfortunately, the training data for like hard bugs is not as common as the training data for simple SQL injection, simple XSS. Like, you have thousands of blog posts around like, oh, this is how you create an SQL injection. If you talk about like hard, crypto engineering bugs, like signature bypass because they did something a bit complex, or SAML signature bypass, that's not well documented. Because people don't take the time to document those vulnerabilities, or don't necessarily have the skill set to do that. Like, there's only a subset of people who can properly like document those. So that's probably what I will spend time on. Like, imagine you have a pen test. You know that it's a pen test to do, and you know that's the fifth pen test this company had. You're probably going to try to find like things that everyone else will miss. And it's the same thing for code review. like, that they probably had a pen test or they probably like some previous code review. So let's look at things that no one else is looking for because it's too hard, it's too deep, or people didn't necessarily have the time because they needed to like look at everything as opposed to spend 5-10 hours banging their head on the same 10 lines of code.
So, sorry, I may be way off base here. One of the things that we do, and we all just did it a minute ago, is we say, how do I break up the code into manageable chunks?
Yep.
And if I hear you correctly, Louis, what you're saying is don't. Understand the wave, the flow of the code as it moves through the system. And you see it. You almost have to become the computer, the compiler, the interpreter, because you have to see how the mindset of the developer was, and you have to understand their perspective and the context. And again, this is, if you go back to AI, context is what an AI can add to a problem, and context is what AI sometimes sucks at adding to a problem. But you have to understand what the goal was and look for anything that moves it toward the goal or an anti-pattern moves it away from the goal, rather than saying, let me look at these 10 lines. Am I on the right track there?
Yeah, that's part of it. I think it's like when you do recon, you need to like keep zooming in, zooming out, zooming in, zooming out. So you need to look at chunks, then go back to the big picture, then zoom back in another chunks or part of the same chunks, and keep doing that back and forth. You can't look at a chunk in isolation, and you can't look at the big picture without looking at the chunks.
Yeah, and I think for me, what it sounds like too is, often code review or just static analysis is about the sources and sinks. What comes in, where does it go out? A lot of what I think Josh was describing is what is the actual flow? What's the data flow or what's a control flow? And the reason I'm jumping on that is that also leads in what is the workflow? What is the business logic that's here? And that business logic for me is something that doesn't really easily fall into one of the top 10 lists. It doesn't fall into this is what everybody has the same blog post about SQL injection or string concatenation. I think that supports exactly what you were describing too. So with that in mind, you were talking about kind of like taking notes or understanding code. What do your notes look like? Are you writing your own control flow? Is it just, do you have smiley? Do you have a bunch of emojis to come back to certain areas of code? If we peeked over your shoulder, what do we see?
I wish I had an emoji to put like a red flag, sad face, a happy face. That would be pretty fun. So it depends. I think you have like a lot of indicators of good and bad code. And sometimes, like depending on how much time you can invest in that target as well, if it's something you're going to review again and again, you can take like deeper notes, like because you want your reviews to compound over time. Where if you like just doing like a quick swap, it's a bit harder to like take deep notes. But I usually try to notice like everything that doesn't feel right. It's hard when you start, but then you get better at it. But like there is a return value, they're not using it. They have a lot of complexity in that part of the application. Doesn't mean it's bad security-wise, but if it's complex, it's going to be hard to maintain over time. So that's something I put notes on. Something that feels weird. Some checks as well, like if there is a check, they are preventing a threat. So the threat is here. I don't even need to guess what is happening. I know the threat is here because they're trying to prevent it. So from that, I just need to say like, okay, there's a check here. Let's review it later on or right now because I know there is a threat. So it's pretty obvious. And but the level of notes really depends on what I'm doing. What is really important when you take notes or run a code review is never ever use the file name and the line. Use the file name, the line, and the actual code because line change over time when you update your Git repo and things like that. So that's a mistake. You get caught one and then but yeah. And everyone is different. So find the right level of notes that works for you. I also like to add my own like micro thought process because when you are 2 months later in a meeting with someone or need to go back to explain a bug to someone else, you really don't want to like have to run into the code base and try to understand like, okay, what was the assumption? What they did very wrong? What was happening there? So just like, okay, let's write down what I thought was bad or was good at the time And so this way I have that on my notes. Yeah.
One thing too I want to jump on is that aspect of is trying to define our terms of art, even though they are very much more art than science. And that's why I asked about the hard bugs. Complexity is one of those things that also creeps up. There was a great blog post from Daniel Stenberg of Curl that came out just at the end of May last year, or this year, that was talking about the complexity of Curl. And it had a tool that measured a measure of complexity of code, and also just talked about like function length, lines of code in a function. These feel at least like they're things you can measure. They feel kind of like brute references. Is that a type of complexity that you look for? What other types of complexity are you looking for here that might be brittle, as you say?
So code flow. There's a really good book on Golang, but not related to security, but just Golang, where they tell you to align the happy path to the left. So this way it's easy to trace the code instead of having like if else, and like going like full like Christmas tree. Also, unnecessary checks, size of a function is one as well. It's hard to explain. Like once you have read enough source code, you know what something should look like. And then everything that derives from that is probably like complexity in a way or too much simplicity in another way. But since it's hard to gain that understanding of like what you get from reading a lot of code, a good way to find those complexity or those lack of complexity is to spot the differences. Basically, you take two code bases and you compare them. It's a lot harder to like come up with ideas than it is to just say like, oh, they have something here. Here they're not doing the same thing. That one looks a lot more complex. Here they have something here, or they don't have it here. What's the security impact on that? And yeah.
No, I like that. And one of those things too is I did want to touch on languages for a moment, because you did mention Golang just as an explanation, as an example of, call it style or recommendations. I'm always hesitant here because I don't want to get into language wars, and other than Perl being an abomination, I think all languages are fine. But how much does the actual, with that joking aside, how much does the programming language itself influence the code review? Does it make a difference in code smells, things like that?
Yes. So languages and developers in those languages tend to make the same mistakes because the language, for example, doesn't cover them, doesn't prevent that kind of mistake, or the documentation is not well written. And if the documentation is not well written, people are going to make mistakes because of that. So, for example, if you look at Golang, one of the common issue is directory traversal, because in Golang, the function path.clean, which seems like, oh, it's preventing directory traversal. It doesn't clean. It doesn't do a security clean. It just does a canonicalization. And so, after a while, like those traps, like, okay, I'm looking at Golang. Those are the issue people usually face. I'm looking at Ruby on Rails. Ruby on Rails doesn't have this path.clean issue, but it has often in Ruby on Rails in applications, they deal with strings, arrays of dictionary in a really elegant way. But that brings a lot of security issues as well. So depending on the language, if you know the tricks and the pitfalls, you can start looking for those. And because that, okay, it's hard to get it right. I, as a developer, will get it wrong, or as I may take some shortcuts, so I know like where it's gonna hurt. Like there's a wound, and you put your finger in the wound just to say like, does it hurt here? And yeah.
Yeah, does it hurt here? That's got to be like one of the best like threat modeling questions to add. Part of this too, then there's a segue then from does the programming language matter to, you mentioned you're a developer. How much of a developer do you need to be to do effective secure code reviews?
So I think you need to have written one web application in your life. I think that's you need to I've done that just to be able to have like a mental model of how to write an application. That's, I think, it's going to take you like a day, 2 days. It doesn't have to be like a big application, but just getting like the foundation. Then from that, it's mostly like a question of how patient you can be. Because if you don't know the language or haven't been a developer, it's like how much back and forth you're going to do between the documentation, between like a REPL or LLM to get some details. And also, sorry, that's my friend. How much time you're willing to spend on that language and how hard the target is. Like if you're a brand new code reviewer and you have never written, Ruby before, it's going to be really hard to find bugs in Ruby on Rails. Maybe in a Ruby on Rails application, you may find bugs, but in Ruby on Rails itself, people who are working on Ruby on Rails are pretty smart. They've been writing Ruby for 20 years. So if you come here like with your like enthusiasm and you have never read any Ruby in your life, it's going to be hard. You may get lucky, but it's not going to be easy. So it really depends on like how patient you can be, like how resilient you can be, and how hard the target is going to be.
Part of that too is then I fall on the spectrum of mostly what you describe. You don't have to be a developer every day. You should be familiar with coding patterns, how developers implement algorithms or things that they do commonly. You don't know how to reverse a red-black tree, I don't think, to be a good reviewer, but at least you could, pretend, right? But the reason I'm saying that is you also made a comment about you spend a lot of time reading code, and that to me feels just like you're picking up the patterns, you're reading and understanding. Have you ever made, security code reviews that are just, this code is unreadable? Something like that.
Have you?
Yeah, right. Yeah, exactly.
Not that I really remember of. Like you have bad code that is complex and maybe like 2 or 3 functions will be really annoying to read. But most, like if you look at open source code or like even enterprise code, most of the time their goal is to be able to maintain the code. So it's not it's not bad across the whole code base, but you definitely have part of the application is like, what are they doing? And you spend like hours like reversing, like, okay, so they're actually writing code that then do that. And like, yeah, sometimes you scratch your head for a few hours. Yeah.
And with the increase of generated code being used, have you noticed any, signals that you look for? You know how we can look at something and read it and go like, this was AI generated. Like, have you picked up that sense then when you're doing code review that you go, oh yeah, this section totally not human?
Yes, comments. A lot of comments in code generating by AI. And what is interesting as well is AI tend to be really good at preventing basic issues. Mm-hmm. So you're not going to find like easy SQL injection or like easy XSS because it knows better. But then with complexity, with duplication of code, you have like a lot of hard bugs or complex bugs with a lot of moving pieces that AI doesn't necessarily take into account or knows about. And because they like the lack of context, I think it's like, oh, this code base is growing, and the AI only keep like part of the context. And so you start introducing things that like look fine, but are not actually. Or they are going to change a function that is filtering something, forgetting that in one place of the application, they needed like some other kind of filter. And yeah, so
it's interesting because the context window on an AI is heavily limited. And if you want it to code an entire application, and this is a great question, Mandy, I love this. If you want it to code an entire application, you have to have a big picture view, just as you said before, Louis, a big picture view, but then narrowing, zooming into the chunks. Here's the big picture. Okay, break it up into all the chunks, agile, right? And then, I write this chunk, write this chunk, write this chunk, right? And doing one after another to get through all of the tasks necessary for the big picture. However, the AI isn't able to keep all of that in its head at the same time effectively, right? So is it going to do things that are not only counterintuitive, but counterproductive? Because it could code this small chunk this way or this way. I'm anthropomorphizing. And this way would be helpful for the big picture, but it doesn't know because it can't keep it in its head, and it codes it that way. I'm sorry, I'm ranting now. Go ahead, Louis. I'm honestly curious what you think.
No, you're absolutely right. That's exactly the problem. Is like, they're gonna either forget that they already wrote part of that function, and you're gonna have 20 different functions to do the same thing, and it's And
yes,
then you need AI. You need AI to do the review of AI.
Yeah. Function reuse is so important because it simplifies the code, simplifies troubleshooting, simplifies maintenance massively. It literally cannot be underestimated. And an AI will forget, I wrote that 20 functions ago, and just do 20 different versions of it. Oh, that's a really good point, man.
Yeah.
Code becomes less maintainable when AI writes it.
Yeah, and also some interesting thing I came across last week is Golang introduced a new protection named os.openroot 3 months ago. But the problem is that AI training data is from last year. So this amazing protection, the AI doesn't know about it. And you need to remind it there is this new protection, because otherwise it doesn't know about it. So it doesn't leverage it because it's not part of the training data. So you have all this lag as well regarding what is the best function right now to prevent this kind of attack? And AI doesn't know about this latest function because the training data is too old.
That's a wonderful example because I love path traversal vulnerabilities. I talk about them all the time. And one of the fun things about even the OS root is that it mostly works, except if you're using NPM. There's certain file systems abstractions that you still have to be worried about. And that's hopefully when the LLMs do get trained up, they also remember those exceptions and abstractions, because those are the important asterisks in that documentation. Part of what I wanted to ask too, along the idea of that theme of reading code and even using LLMs to write code, people have told me they found value in LLMs writing unit tests as well as documentation in the code. Where do you fall on the sense of on documenting code and it being useful, it being a distraction, or it being actually misleading because the code can change, but that text may not have been updated?
Yeah, that's a great question. I think it's a good way to document the code or to do test cases. I think for test cases, it's definitely valuable. But what I use it a lot for is I have a snippet of code from a real code base and I want to test it. And I have this function and I need to write code, a main function around it to be able to run that code quickly. So that's what I do a lot, because it's basically taking a hello world and copy pasting the function I have and getting something that compiles. So it's really good at doing that. For comment, I think you may run into the same issue as real comment from people, or real comment, comment from people, from humans, is that you are actually documenting what the AI is understanding of the code, not what the code is doing. And that's something and same thing for humans. It's not a new problem. It's comments are really good, but in training, I said that the first rules of the code review club is never trust the comment. And I think you're going to run into that is comments are good, but they are here to explain what developers or AI are understanding about what the code is doing, not what is really happening.
First rule of Code Club is don't trust the comments. I love that. That's awesome.
We'll make up some T-shirts
I need that
now.
on a sticker. Louis, that's
Need stickers, yeah.
So speaking of training, as you said there, Louis, one of there's a class of vulnerabilities that are absolutely fascinating to me. One is directory traversal. Okay, they're not too exciting for people. Another class is, here is a bug that is 17 years old, 10 years old, 8 years old. And people have been running tools against it. People have been applying their eyeballs to it. There's the old aphorism of with enough eyeballs, all bugs are shallow. I think that needs to be tweaked a bit. But it does point that people still miss things. I wonder for you personally, you do training, but how do you keep yourself trained so that you have a little bit more confidence that you're not missing everything?
So I have a very weird hobby. I like to review CVs.
That's not a hobby. That's a mental illness.
Yeah, we'll find you help.
Yeah.
So, and I think that's really something that people don't leverage enough, is that if you don't learn from the past, you're going to do the same mistake again, right? And it's fascinating to see how much you can learn from reviewing CVs. And the good thing is that I even find new vulnerabilities because the CVs are not patched properly. And it's a great way to get better at finding new bugs, fixing bugs as well, like how people usually fix bugs, and understanding patterns. Like, it's a great way. And also, like, a lot of people who want to get into the industry want to have like a CV under their name to say like, to put that in their resume.
Of course.
And I'm trying to convince people, don't do that, because you have too much luck, like, coming into the equation. Take a CV someone else found and document it. Like, explain why that happened, explain how they fixed it, explain why the fix works or doesn't. And this way you remove like chance out of the equation, because the bug is already there. You don't need to find it. And you're going to show to like a future employer, I can like look at code, understand the code, and understand the security impact of it, and demonstrate that I can write, and demonstrate that I can explain to people in a way that they can understand. And but like CV analysis is probably like one of the best way to get better or stay accurate, stay like pretty good at code review. And people don't do it enough. And I think that's a shame, because if you do like a few CV a month, you find like really good lessons.
Yeah, and it's great to highlight that communication skills. Wonderful thing to highlight. And just looking at those diffs, I have to admit I've done the same thing, not as a hobby, I will say up front though, but those diffs are showing, here was a fix that was literally a one line, and all they bothered was doing was fix a greater than to a greater than an equal, or it was an off by one, something like that. I've seen other diffs that are really instructive of, they actually refactored this function, and they actually added 3 unit tests to make sure this doesn't creep back in. And right there's a big difference in maturity in between those two code paces. And it was just a learning aspect for me too, about also what you were saying. I'm kind of repeating it back, so I don't want to steal your thunder, but it was so good that it's worth that echo of understand how it was fixed, because that's also where the value of a code review comes from, right?
Yes, exactly. And it's also like, we were talking about how intimidating it is to start. That's a good way to start on a new code base. Look at the old CV in that code base. So you make the code a little bit less intimidating, because you already like have a footprint inside the code base, because you look at previous CVs, and also what you don't necessarily need to look into, because all those CVs have already been found.
I'm gonna summarize slightly. We've been talking indirectly and directly about patterns this entire time. If you want to understand how CVEs are found and written, go review CVEs. If you want to understand how to do manual code review, understand the context in which code is written. If you want to excel at code review, look at both the big picture and the overall pattern, and then how that pattern is realized and embodied in the smaller chunks and the individual functions. And the biggest pattern of all is, of course, first rule of Code Club: don't believe the comments.
We're going to get t-shirts.
Yeah. Now, of course, the second rule is going to be, don't believe the advice you hear. I'm not sure. That doesn't sound like it's a good self-interest for a podcast, but I'm getting worried here.
Don't believe the vibe. Don't believe the vibe check.
Yeah, I guess. Yeah, I did skip any aspect of vibe coding. Is there such a thing as, since we're near the end, I'll just squeeze this. Is there such a thing as vibe code review, security code review?
It
I
sucks.
think like everyone is trying to do a good job, but sometimes you just don't have the time. And sometimes you need to rush through it and you need to just skim the code and say oh, good, bad, terrible. And yeah, but unfortunately that happens. But,
Never truer words have been said. Speaking of time, we are ourselves running low on time, but there's also that theme of how do you know when you're done with a manual code review? Because there is a lot of code out there. You can't just necessarily focus on one repo. If you've got 10, you've got to get through, or you're doing consulting and you're time limited. What makes you feel like you're done?
So if you're doing that for a client or internally, it's pretty easy. You're done when the money runs out.
All right. Fair answer.
Otherwise, I think it's kind of, you're never done, especially since the source code is still moving while you're reviewing it. So reviewing it here, then it changes over time. So I think for me is when you feel like you have not been progressing on the code base for 10% of the time you are willing to spend on it. So progressing not as in finding new bugs, but not as in finding new interesting patterns or understanding the code base better, or just finding new attack surface, new IDs. You're just grinding for 10% of the time. And you're okay, it doesn't work. And I think at that point in time, what is critical is go for a walk, take a shower, whatever, sleep on it, and then come back for a little bit more. And if it still doesn't work, write down all your notes and revisit in 2 months, a year, or something like that.
I love, keep that mind fresh. That was one of the things that makes us very distinctive and unique compared to the LLMs. Louis, we've thrown a lot of numbers at you. There's also, I'm sure you've looked at not only hundreds, but probably thousands, if not tens of thousands of lines of code. But before we let you go, I just want to go down to the number 3. And we asked all of our guests to describe AppSec in 3 words. So hopefully that's a little bit less, not quite as hard as a few thousand lines of code.
Okay, so if it's AppSec in general, I will go for developers are friends. That's probably my view of AppSec. That is the most important when you're doing AppSec internally or externally. Is we all in there to help each other get better. And people often see that as this confrontation world, but I think the more you talk to developers, the more you realize that they're exactly like us. And they love security stuff. They love security bugs. They love vulnerabilities. Even if it's in their code, unless if you're friendly when you're telling them your baby is ugly, that can go a long way.
Well, you've been very much a friend to us and helping us learn quite a bit about manual code review. I appreciate that. Thank you, Louis.
Thanks.
We've also had great time with our friends Josh and Mandy. So everyone, please send a thank you to them as well. Thank you all for listening to us. This is a short episode this week. Please do remember, though, to subscribe. Check out the show notes. We'll throw in a couple links that Louis mentioned as well, and share us on the socials. And speaking of numbers, check out 39 by Sphero. We'll see you next time on Application Security Weekly.